All right, hello everyone. This is the second example to our introductory lecture on Excel and Python. And I wanted to, in this example, show you how to install a version of Python on a Windows computer and show you some really quick basic examples of some things in Python. So to install, I want you to come over, click on your web browser, and do a search for what's called Anaconda. So Anaconda Python. So and just go ahead and run that search, and you should see something like this: Anaconda Python distribution free download. Okay, Anaconda is basically a set of software that allows you to interact easily with Python. So I want you to make sure you select Windows if you're on Windows, or Mac if you're on Mac. If you're like me, you do Linux, you can also install it there. And choose the Python 3.7 version, right? So you click download there. And it's reasonably big. It's about 460 megabytes. Hopefully that downloads pretty quickly on this computer because I'm at the university. And I have super fast download, so hopefully that runs quickly. So it's running here. Okay, so it downloaded, and I go ahead and click run. And we will follow it as it installs. Oh, there it goes. Okay. I picked 64-bit. Probably that would be the same for most of you. I'm going to agree to the license agreement. Just me, I think, is fine. I recommend that you just install it in the standard folder. Oh yeah, this is an issue. So I have this issue too. So when you go to install, if you have a space in your name, and I forgot to worry about that when I made this virtual machine, which I'm using here, it's going to cause problems. So if you get to this point, you have a space in your name, don't install it in the standard spot. Let us pick a different place to install it. So if you look here, this is in C users / Douglas tree. Let's go back to the C drive, and let's just pick let's see, where do I want to do it? Let me do it in public. Or should I do it in program files? I'm going to pick program files. Okay, so let's do C / program files. Okay, and let's see, let's go back and see what it recommends. It recommends Anaconda 3 is the name. So I'm going to copy that, browse, come back here to this PC, C drive, that's the local drive, and program files has a space in it too. That's terrible. Let's just do it on the C drive. C drive, Anaconda 3. Does not like that. What a bummer. I remember this being a pain with forward too. Well, let's try users. See if we can put it there, if it'll let us write to that directory. Nope. Try users public. See if it lets us do that. Anaconda 3. That'll let us do that. Okay? So we're going to go ahead and try that. Users public Anaconda 3. We'll see if that gives us any issues. All right. You can just go ahead and keep the stock thing here. Click on register Anaconda as my default Python unless you know what you're doing. And this will go ahead and run and install. Hopefully it's reasonably quick for you. All right, so that took a little bit, but the installation is now complete. So I'm going to go ahead and click next. And great, thank you, PyCharm. And I don't want to do that, so I'm going to unclick those guys. And I finished. Okay, so now I come over here And notice that it's installed a bunch of things here. The new things it's added is Jupyter Notebook, Spyder, and usually there's an Anaconda. Maybe they did away with this. Let me just see. An Anaconda Navigator. So I'm going to open that first, Anaconda Navigator, just to show you what comes with it. Let that run for a second so you get the circle. All right. Okay, don't show it. So you get a bunch of things here that come with this. Okay, we are going to focus on Spyder. So we're not going to do Jupyter Lab. We're not going to do Jupyter Notebook, at least for a while. We're going to do Spyder. So one way to launch it is by opening Anaconda Navigator and clicking Launch on Spyder. So again, some of this appears to be taking a little while. You can see it's launching in the background. Brings up the little splash screen. Okay, so this is what Spyder looks like. Thanks for letting me know. There's a new update available. Okay, I have a text editor on the left. I can change the font size here, which I'm going to do so you can see what I'm typing. I'm going to increase that from 10. Let me increase it to 14. Okay, now you can see it's a little bit bigger. So I have my text editor on the left, and I have my console on the right. The text editor is where I'm going to enter the code, and then it will run and give me output on the right. So I'm going to move my little picture up to the top so we can mess with the console. Okay, so the very first thing that you can do is to make a simple Hello World document. Okay, Hello World is the classic programming first program. All right, so first I want to save this into a location I care about. So I'm going to come over here to where my directories are, and I'll find my 263 directory, and this is lecture 2, and this is a video, and I'm going to save this as hello world.py. Okay, we give the .py extension to Python files. That will tell us it's a Python file. Okay, so hello world.py, and what I want to do is have this print the text hello world. So to do that, I give it a print and parentheses, and I just typed the first parenthesis. It gave me the second one, the editor did, and I'm going to give myself some quotes, and inside the quotes I'm going to say hello world with an exclamation point. All right, that's all I'm going to do. I'm going to save this. So notice I have a little asterisk up here once it's changed. So I can save it by doing File Save, or I can hit Control S, or I can click the Save button. I highly recommend that you save often when you're coding. I get so used to it, I just hit Control S all the time. All right. So now I press the green button. This will run the code or execute the code. And let's see, run settings. I want to execute in the current console. That will execute right there. Okay. And this asks me what my working directory is. We'll talk more about the working directory later, but I'm going to say let that be the directory of the file being executed. Okay. Run that guy, and it says run the file. This is my working directory, and look, it prints it out, hello world. Okay. So that is my first program. Okay. Now I'm going to open another program. If I come over here, I'm going to open this Introduction to Python. And this, similar to the Excel example, this is an example that's meant to highlight some of the things that you can do in Python. And you should take some time and peruse through this file and practice some of the things that are going on and try and understand every line what's going on. Okay. So the first thing I want to point out is notice that these are grayed out. They are grayed out because I have a pound sign in front the pound sign is a comment character. And the Python interpreter is going to ignore everything that has a pound sign in front. So if I, remember I had a hello world. So if I put print hello world here, and I want that piece to run, and I press save, and then I did a Control S, and then I click run. Okay, now oh, this is the worst. Should I? Let's see. Let's come up here. Oh, sorry about that. So I went to run this, and it's asking me for some input, and I tried to kill it. So let me just stop execution. There you go, interrupt. So, but notice it printed hello world here. Okay, maybe that was lost. So if I'm going to try and comment out everything below here, just for now to show you about the comments. So let's see, I think Control 1 will add a comment to everything I highlight. So there's a little trick for you. So if I want to comment multiple things, I want to comment or uncomment it, I press Control 1. Okay, so now if I run this guy again, now it'll just print hello world. Now notice if I put a comment in front of that piece and press run, first note, if I just press run without saving, it saves it for me. And now it runs it and it doesn't print out hello world. Okay, so the comment just makes the Python interpreter ignore that line. So comments are super valuable for noting what's going on in the code. Okay, so I'm going to now uncomment all this stuff with a Control 1. Okay. All right, so this says the first thing we're going to talk about is input output, or I/O. So if I want input, I type, if I want something from the keyboard, I have the keyword input with parentheses, and that is going to have a variable, and the variable that will then need to be assigned somewhere, and I'm going to assign it to this the value that will come from this input. I'm going to assign it to this guy, name. So let me run this piece. It says, what is your name? And I'm going to type Doug, that's my name, and hit enter. Okay, and then it prints, your name is Doug. Okay, so input and output are run by input and print. Okay, now I'm going to comment these out because we're done with that, and I don't want to mess with them again. Okay, so here it says, ask the user for their age and print it to the screen. So I can say input, what is your age? Question mark. And I can say age is equal to that guy. And then I'm going to print your age is, and then I want to have the age. Okay, I keep doing this, so I'm going to explain. So I can use either double quotes or a single quotes, the apostrophe, but I need to be consistent. So I'm picking to do double quotes here. We'll talk about strings and variables, I think, or did we talk about that in class? I think we did talk about that in class. I'm just looking at my notes to make sure. So this is a string variable. I think we'll talk about data types another day. But this is a string by putting it in quotes, and this is a concatenation. So this is going to add the age onto it, and age is also going to come as a string. So when I run this guy now, it asks me what is my age, and I am 34 years old, and I hit enter, and now it says your age is 34. All right, so we'll comment that out, let this go. Now let's look at how to do arithmetic. So arithmetic is done with some of the similar symbols that I had from Excel. So plus, minus, multiplication is the asterisk or star, division has the divide. There's a modulus, which I'll explain in a second. And notice that to do exponentiation, to do powers, it's different than Excel. It's not the caret, it's two asterisks. Okay, so if I look down here, I can press run and see what's going on. I have 3 plus 2. That prints out a 5. 3 minus 2 prints out a 1. If I do 3 times 2, that gives me 6. 3 divided by 2 is 1.5. Notice here, if I wanted to put two things on one line, I can just put a little semicolon and it'll run both of them. But if I don't do the semicolon, it's going to freak out at me, and it's not going to like that. Okay, let's say invalid syntax. A syntax error is an error when you do something that the language, it's not allowed in the language. Okay, so I can't have a print and then another print right after it. I have to have a semicolon if I want to have them on the same line, or I could just put them on two separate lines, and then I don't need the semicolon. Okay, the modulus gives me the remainder. So 3 divided by 2 is 1 with a remainder of 1. So 3 modulus 2 gives me a remainder of 1. Suppose I want to look at something else. If I want to look at, say, 5 divided by 3. Well, 5 divided by 3 is going to give me 1 and then 2/3. So the remainder is 2. So if I execute that, I better change this so we don't confuse ourselves. 5 modulus 3. That will give me the remainder of 2. Okay, so modulus is useful for getting the remainder. And here I told you if I want to do the power, I want 3 squared. I use the 2 asterisks in a row to get the 9. Okay, so this says how many seconds are there in 6 years and 7 months. So I want to print, let's see, I have 6 years. So how many seconds are in a day, in an hour? Let's see, I have 3,600 seconds in an hour, 24 hours in a day, and let's see, there are 365 days in a year times 6 years, plus, and then 7 months. I don't say how long the months are, but let me do 3,600 times 24, so 3,600 seconds an hour, 24 hours in a day, times, let's say, 30 days in a month on average, and that should be that. Okay, so if I print, that's what I'm going to print out. Now there's just a string. I put that in quotes. So now I'm going to copy that, come over here, comma, and paste, and that should give me a value of, let's see, I put an equal sign of however many seconds there are in 6 years and 7 months, thereabouts. Okay, let's see, it's about 191 million seconds. So that's a lot of seconds. Okay, in addition to doing arithmetic, I can assign variables, and I can do comparison. Okay, so this operator here, the single equals, this is called the assignment operator. This takes the value of 4 and stores it in the memory associated with the variable x. Okay, so it associates x with 4. The way I think about variables are like ice cube trays. Okay, they can hold stuff. And so this is going to hold a 4. This is not an equals sign. This is an assignment operation. The equals operator is something that compares two values. So what I'm doing here is assigning x to be 4 and y to be 3. So this will print out x is this and y is this. And then I want to say, is x equal to y? And I do that by this comparison operator, which is a double equal sign. So let's run that and see what it is. So I have x is 4, y is 3, and so does x equal y? False. So this returns not a number, but it returns what's called a Boolean value, a logic value of either true or false. Then this asks, is x greater than y or x less than y? X is greater than y, so that's true. X less than y is false. Finally, I can do some other things. In addition to simply assigning something, I can use this plus equals operator. The plus equal operator is like doing x equals x plus 5. Okay, I said equals, but remember this is not equals, it's an assignment operator. So what I'm doing is taking the old value of x, which is 4, and I'm adding 5 to it, which should make it 9, and I'm assigning that to the value of x. So it separates in time the right-hand side, which it evaluates first, and then it dumps it into x. So that's what plus equals is doing. Both of these are equivalent statements. So I can show you that. So if I comment this one out and run it, and then I print x, that gives me 9. X plus equals 5 is 9. Okay? Or if I comment that guy out and uncomment that one, that is also 9. All right? So let's see. Check if 5 cubed is greater than, less than, or equal to 3 to the 5th power. So I have 5 cubed and 3 to the 5th power, and I want to say, is it greater than? So I'm going to print 5 cubed greater than 3 to the 5th power, print 5 cubed comparison equal to the 5th power, and print 5 cubed less than. All right, and I'm going to run that guy. I saved it and click run. And this says false, false, true. So it's false that it's greater, it's false that it's equal, but it's true that it's less. And we should be able to see that by printing out what those values are. So I'll copy and paste that there. Copy and paste this there, 3 to the 5th, 5 to the 3rd, and we'll see what those values are. So 125 and 243. So yes, we would expect that 3 to the 5th is greater, so 5 to the 3rd is less than, and so we confirm that everything is true. Okay. Finally, we can use logic on Boolean variables. So if I have a true and another true, that gives me true. So something that's true and another thing that's true gives me a true. Okay. These are called Boolean logical operations, and they're really valuable when we're going to talk about if statements in a couple of days. All right. So there are basically two different things that can go on here. So I can have true and a true, and that gives me what? That gives me true. But if I have true and a false, that gives me a false. Okay? Because true is not equal to the false, so that gives me a false. Okay? So if I have false and true, that also gives me a false. Okay? And if I have a false and a false, that gives me another false. Okay? So you can see that here. I define a value of my bool, which is a Boolean value of false. And I can check what happens if I take it and make it and with it. We can run that one out and see. So we'll just look at the and for a minute. So if I have false and true, that prints out false. But if I come in here and make this one true and print that guy out, now I have true. Okay? I can play around with this. I can make that false, and I can make that one false, and run that guy, and there we go, false again. Okay? So basically, the and only allows something if both things are true. So think about that logically. If I said, what happens if this apple is red and the apple is bruised, and I say, is the apple red and bruised? I need both of those things to be true if I have and, right? I say, is the apple red and bruised? And you'd say, yes and yes. And you need both of those to be true in order for the whole statement to be true. Okay. On the other hand, there is an or, and if I have a true thing or another true thing, that gives me true. If I have true or false, that gives me true. And if I have false or true, that gives me true. Okay? So in this case, now if I said, is the apple red or bruised? If the apple is either red or the apple is blue, then that statement is true, right? So if I ask, is the apple red or blue? Is the apple red or bruised? And you're like, well, the apple is bruised, but it's green. You'd be like, yes, that's true. The apple is red or bruised. Yep, that could be true. Okay? So you can come down here and look at the or statement, and we can play around that guy. So if I say my bool is false, false or true. Let's look at what happens when I run that guy. And false or true evaluates to true. Okay, but if I make false or false and I run that, then false or false evaluates to false. Okay, the last one is the not, and the not just flips it around. Okay, so not true is false and not false is true. So this here is saying not, I don't know why there's a not true there. Not false should evaluate to true. So yes, it does. And if I make my bool true and I run that, then not true is false. Okay? So now you can combine these. You can make sort of logic games, and you can print, say, true and false, or false and false. So see if you can figure out what that is going to evaluate to before you print it. I'm going to put parentheses around these so that they do them in the right order, because I want false and false first. So false and false, what should that evaluate to? That should be a false. True and false should evaluate to a false. So false or false should give me a false. So let's run that. And invalid syntax. What did I do? Oh, I made them capital. Excuse me. Or and. Run that, and indeed it gives a false. Okay? And you can play around with that and see if that makes sense. Okay? So these are the examples I had for Python, installing it and doing some basic arithmetic, comparison, and logical operations. I hope that makes sense, and wish you the best.